This is the MSD system. So obviously we've got our mass here in the carriage. This is our spring, and then the damper is this little piece inside the oil to cause viscous damping. And for this one, we've got corn oil inside the container. Here we've got a scale that will help with calibration. And then this part is the actual part that records the voltages. So this is a linear variable differential transformer, or LVDT. So basically there's a main coil in the middle here, and then two coils on either side, there and there. So based on how far this conductive, I think it's iron or steel, rod moves up and down inside there, you have a voltage difference. So the currents are intersecting. So if the rod is further on this side, you'll have a positive or negative voltage. If it's further on this side, it's vice versa. We also have different springs that we can put on the system. This one's a little thicker. The coils are thicker, so you probably have a higher stiffness for your spring constant. And then here we've got more mass that we can add. The mass was weighed before I put it on the carriage. You'll need that in your calculations. Once the mass was added, this is our 0 point. So we needed to calibrate the differential transformer to read 0 voltage when this mass is added on the carriage. So to do the calibration, basically we can look at the graph over here, and this is reading in real time. So we've got a voltage of 0 right now because I've already calibrated it. But if you hadn't had it calibrated, this is how you calibrate it, and you rotate it, that little piece. And now you can see we're a little below 0. So to get it back, I just rotate it back the opposite way. And now we're back at 0. Once we have our 0 point, we need to calibrate the voltage versus displacement, or displacement versus voltage. So basically, you take a pair of calipers here and deflect the mass, say 0.25 inches, and then deflect it 0.5 inches, and then an inch. And you keep doing that for several points and record the voltage readings for each one of them. And then once you have that, you can graph that data and get a curve fit line to convert the voltage readings into displacement. Also, the LVDT is hooked up to this controller box here. So we have power going out here. So obviously you need to plug that up first. And then this part here is the data output. And that's hooked into a DAC system, which you're probably familiar with. And then, of course, that's hooked up to my computer via USB. And now with everything set up, we can start recording data. So I'll hit run on the VI. So now it's recording voltages in real time. So I'll come over here and displace this. I usually try to displace it about an inch or less. If you displace it anymore, you'll get outside the linear range, and you'll get a lot of noise in your graph. So once I displace it, as you can see, I'm bouncing it up and down here, and we got a little bit of sine wave behavior. But I'll displace it about an inch here and then let go. And you can kind of see the behavior is a sine wave. It dampens out pretty quickly, probably within 5 or 6 seconds, as you can see. But it's sampling at 1,000 hertz, so you'll have quite a few data points, and you'll be able to get a smooth curve. Also, in our VI, in the background while the test was running, it shows you in real time the data, but it also saves it into a comma-separated variable text file format. So that's just converted into an Excel file, so you'll be able to graph. And that's it.